Okay, hello everybody, dear colleagues, dear engineers from North Macedonia, from all parts of the world. I welcome you to this today event, which is titled ProtaStructure Suite Macedonia Launch Webinar. My name is Sergey Churilov, and I will be a moderator of this session of this event, and I'm greatly honored to welcome you to this webinar of ProtaStructure Suite to all our engineer community. This event will be a significant leap towards improving structural analysis capabilities for all structural engineers. What is ProtaStructure? ProtaStructure is a suite of programs which is very powerful, and it can undoubtedly enhance our ability to design and analyze structures with great precision and efficiency. It can significantly enhance the process of design and the analysis, as well as the skills for different types of structures, particularly buildings. And in this way, it is making this process more accurate and efficient. This software is particularly important for Macedonian engineers because it covers very crucial aspects of the sector. So I will name a few, and later during the session, we will hear more about that. So ProtaStructure Suite offers best BIM integration for starting, coordinating, and sharing models. It includes bidirectional links with the latest versions of Revit, IFC, DXF, SAF, and other recognized BIM and analysis formats. The program also contains advanced analysis capabilities such as linear elastic analysis, equivalent static earthquake load, response spectrum analysis, time history, pushover, concurrent correct and uncorrect analysis, stage construction, P-delta, and much more. It offers and allows fast multi-material building modeling using physical structural members, and it supports concrete, steel, and composite design from one central structural BIM model. It has very convenient user-friendly interface. It features an interactive user experience with extensive in-product learning, contextual help, live updates, and dedicated technical support from professional engineers. Also, it includes design capabilities in incorporating the leading international codes, including seismic requirements. So this assures that the design process will be accordance to all the national standards as well as Eurocodes, which is particularly important for Macedonian engineers. It also features very powerful and fully automated engineering drawings and fabrication detailing for reinforced concrete, steel, and composite structures, as well as automated quantity takeoff for cost and comparison. I'm also very pleased to announce that ProtaStructure Suite includes Macedonian language interface for input and for output of the results, which makes it more accessible and easier for use for the local engineers. This webinar will be scheduled as following. First, my colleague Volkan Öğüt will give us the presentation and the most important features of the software, and at the end we have time for a Q&A session. We will be happy, of course, to answer all of your questions you may have about the software and its applications. So you can use the chat box on your screen, on the right of your screen, to post any question during the session, and we will try to answer all or most of them. And now, without further ado, it's my pleasure to introduce Mr. Volkan Öğüt as our lead panelist for this webinar. Just a brief introduction. Mr. Öğüt works at Prota Software as a technical support specialist, and he will take us on a detailed tour around the capabilities and features of ProtaStructure Suite. His extensive experience and knowledge can provide us helpful insights on how we can manage this powerful tool in our daily work. Mr. Öğüt, the floor is yours.
So thank you for the introduction part, Mr. Sergey. So let me introduce myself. My name is Volkan Öğüt. So I've been working as a civil engineer, actually technical support engineer in Prota Group for 12 years. So in this webinar, you can see our agenda in here. So we will just start with our overview of our products. Then I'm going to continue with the live webinar. And at the end of the webinar, I will take your questions and we will have a Q&A session at the last part. So as you see in here, project delivery stages consist of different processes such as modeling, design, analysis, fabrication, detailing, and BIM. So ProtaStructure is an all-in-one software that can accomplish all these phases as a single solution. So ProtaStructure Suite includes 4 different softwares. So first one is ProtaStructure that you can model your building, you can run finite element analysis, and you can design the each component of your structure in the ProtaStructure side. Then you can export your model to the ProtaDetails. In here, with just couple clicks, you can obtain, you can generate all reinforced concrete details. We have also macros in here, so you can quickly create retaining wall details or stair details as you wish. If you have a steel members, you can add your connections, you can obtain reports, or you can get the fabrication details in ProtaSteel. Of course, you can share your model with the other BIM platforms such as Revit or, for example, Nemetschek Group softwares via SAP format, or you can use the IFC. So as you see in here, we have more than 40 years experience in the structural engineering, and our product supports 10 different languages, 25 international design codes. We also provide more than 250 design guides and manuals in our knowledge base. By the way, we are an expanding company, so now at this moment we are selling our products in 90 different countries with our 24 partners. You can see our headquarters in Poland, Turkey, Malaysia, and also we have a lot of resellers on all around the globe. So since 1992, we have been developing the ProtaStructure till this moment, and we have been selling the software in 90 different countries at this moment. So generally, engineers are using different softwares for modeling, design, component design, detailing, fabrication, and structural BIM. But with ProtaStructure, you can do all these stages with a single software. So actually, being all-in-one software differentiate us in this case. ProtaStructure is used by thousands of leading engineering consultants around the world, such as Jacobs, Ecom, Renaissance Construction. So you can see really well-known companies who are using our products. So let's see in action. As you see, once you launch the software, there will be a welcome page, and you can quickly create a new project from here. What we did in here, we have just generated a bunch of templates that you can select one of them. For example, in this case, I'm going to use the Polish one. So these actually templates are generated regarding to the project delivery for that region. So let's just click OK. By the way, I'm going to insert a new name. Let's say Webinar 2. There are several ways to start a project in ProtaStructure. First one, you can import, maybe you can import your structure via IFC or 3D DXF or 2D DXF with external reference drawing. Or you can model your structure from scratch with the grids or orthogonal axis generator. So what I'm gonna do first, I would like to show external reference drawing. Let's say that we have architectural plan, and we can import all members from this architectural plan with just a couple of clicks. Of course, these architectural plan can be placed as a background, and you can just create your grid members or column, beam, etc. on it. Or we can simply import all members from via import button over here. Okay, let me show also imported members in 3D view. So in this case, I would like to show our features from scratch. So let's just continue with the orthogonal axis generator, but first I need to deactivate this background drawing. Let's just go to the modeling tab and click on the orthogonal axis generator. We can pick a point on screen and we can specify the axis spacings. For example, let's say 5,000, 2 times 3,000. We may have axis spacing, and let's say 4,000 and 2,000. So as you see, all grid system has been generated just like this. If we want, we can just change this straight axis with the curved one. You just need to pick 2 grid intersections, and sorry, I just need to select curved one. Okay, so in here we can press F2 button and we can specify the curvature distance just like this. Also, you may have different facades for your structure. So what I'm gonna do, I will draw another. By the way, let me turn off the email. Okay. So by the way, we can draw all this, so any kind of axis via picking grid intersections just like this. Okay, so we have created our grid system. Now we can add our columns, walls, beams, and slab elements. So I'm gonna start with the columns. You can just click on the axis intersection, or you can just box around on the grid intersection, so to create a column in here. Of course, we have column properties. Column width, height can be changed in here. If you want to switch this values, you can simply click on this B1, B2 button over here. And of course, what we can do, we can change section manager as we wish. For example, we have circular or any kind of column section can be used in here. So what I'm gonna do, I will just align this column on this curved axis. So again, we can just let me roll it back. Okay, we can simply change this B1, B2, and we can align on the y-axis just like this. Of course, you can, for example, you can use the circular column, and we can simply click on the axis intersections to place this circular column just like this. If you want, you can use the, for example, L-shaped column, and we can rotate as we wish. If you want, you can use cursor keys to reposition the column. So in this case, I'm going to slightly change the position just like this. So what I'm going to do, I will continue with the wall members. So to create a wall member, you just need to pick 2 points, and you can see that our wall members are being generated. We can also add an additional wall at the middle. So we can quickly offset an axis to the desired place. If you need, you can also turn off these axis balloons just like this. I'm going to also create an additional wall, shear wall in here. So what I'm going to do, I will just merge all these wall segments in a single piece. We can use merge vertical members, and now you can see that all these wall segments are merged in a single piece. We can quickly generate our reinforcement in it. For this purpose, we are using polyline wall editor. In here, you can use the automatic containment. You can add head zones. So different corner bar diameters can be used in here. And once you click OK, all reinforcement will be generated automatically. Of course, if you want, you can customize it. You can add your rebars, add tie bars, so any kind of stirrup can be generated there. So this part is customizable. Okay, let's continue with the beam members. Again, I'm gonna create some beam elements. You can just box around, or you can draw along the axis. But I just need to turn off an option, otherwise the software will add beams on the shear walls. So make sure that you have turned this off. Okay, so what I'm gonna do is I will just box around all these along the axis, and as you see, there is no overlapping in here. So again, we can create all these beams with just a couple clicks. If you want, you can also draw these beams one by one. It's up to you. Or generally, I prefer to use this boxing around feature. So just like this. And at the end, I'm going to use the curved beam option. Also with F2 button, you can specify the curvature distance, just like this. So to create secondary beams is also easy. For example, you can just hover over on the beam, and you can snap to intelligent points in here. Let me do this again. Okay. As you see in here, we didn't create any axis, so for secondary beams, we don't need to use, we don't need to create axis before we insert the beam members. You can also press the F2 button and specify the distance from starting point. Okay, just like this. So I'm gonna delete this part. By the way, I didn't mention, but we can create any kind of column section with the polyline feature. For example, even such a complicated shape can be generated as a column section. So what we can do, we can quickly convert this a column, and we can change the reinforcement inside in here. So let me delete bars. We can simply add our bars in here. For example, let me show intermediate bars can be added via this. Okay. Okay, so any kind of rebars can be added like this. You can add tie bars also. we can add extra reinforcement on that side. Okay. So even such a complicated geometry can be generated in here. Yeah, I'm gonna delete this column. So what I need to do before I slab, I need to activate the Eurocode 8 because soon I will create my combinations. So in here, let's just select the codes, and we can use the Eurocode 8 base code for this model. So now I can add my slab members in here. Let's just quickly create our load cases and load combinations. For example, you can select the seismic loading in here, wind loading, soil pressure, or for example, snow load can be selected. In our case, there won't be any soil pressure, so I'm going to skip this part. Okay, so as you see, all load combinations has been generated in the load combination editor. Okay, now we just need to change the thickness. For example, let's say that we have 15 centimeter thickness. If you want, you can change the elevation from here. Concrete cover or loads can be changed in here. I'm gonna use our predefined loads. Of course, if you want, you can insert your own value with the enter value option. Impose loads, if you just right click, you can see code based impose loads in here. So I'm gonna use the residential floors option. Okay, we can simply click on the beam region, and our slab members will be inserted just like this. So now let's add some loads. In here, in the loading tab, we can assign all wall loads with just a couple of clicks. For this purpose, I'm going to select the wall load, and let's say that we have 20 centimeter wall load thickness, and of course we need to change the wall height from here. Once you just box around all these beams, wall loads will be applied. So let's just click OK button. We have really extensive loading editor, so you can insert almost any kind of load in there. So our wall loads have been inserted. So I'm gonna, for instance, delete these wall loads. Okay. Let's also delete this load on the shear wall. There won't be any wall load here. Okay. So what we can do, we can copy this wall load, and we can create a particular wall load by selecting this beam. So I'm going to use insert wall by dragging, and we can create a particular wall load on this beam. So let's continue with the slab loads. In the loading tab, we have an option that you can create line, area, or point loads in here. So let's say that we have a line load. We may have 10 centimeter brick wall, and wall height will be 2.85 meters. Okay, let's draw on the slab, and that's all. Okay, so I would like to create some cantilevers. So we can use type 12 for this purpose, and then you can specify the length of cantilever. Let's say we have 1 meter length for this cantilever, and it's being created just like this. Also, you may have a different geometries, so you can draw any kind of geometry as you wish in here, and we can even continue with the arc members. So we can simply use this outer edge for this cantilever generation. Okay, so almost any kind of cantilever can be created and designed by the finite element method. Okay, so let's just insert new stories. By the way, let me turn off my camera. So let's just add new stories. So I'm going to insert a 5-story building. So the last story will be a steel story. So steel elements will be there. And we can generate this story information to the second, third, and fourth stories just like this. Okay. So in the edit story part, you can play with the story heights, labels, for example. Let's say that we have basement, first story, second story, third, and we may have roof. You can also insert description in this part. Footing depth is controlling the starter bar length, so we will have 50 centimeter thickness foundation depth. You can also, if you have rigid basement, you can insert in here. And the last story will be steel, so I'm going to select the structural system as steel. Okay, let's just click OK button. And we can also activate the 3D physical model view. So in here, I would like to, the last story can be a flat slab. So we can simply delete all these beams with just a couple clicks. So I'm going to use the selection filter and I will just filter out beams to delete them. Okay, just like this. And if you just click the delete button on your keyboard, all these beam elements will be deleted. Okay, so I think it's not selecting due to the selection filter. Okay, so what we can do, we can use slab table to increase the slab thicknesses. For this purpose, we can use member tables. Okay, we can select the column and change the all values for this column. Let's say we have 30 centimeter thickness for these for the 4th stories slabs. We can also add some slabs for these elevator shafts. Okay. So I'm gonna delete this shear wall, and at the last story we can have some column members on these axis intersections. So for example, if you're suffering from the punching check, what you can do, you can add, you can use our new feature, which is drop slab patch panel. If you want, you can add drops, and you can specify the drop width and drop height in here. Patch layouts can be added. If you want to add a separate reinforcement just for this region, you can use patch layout. For detailed information, please take a look at my previous webinar. Okay, so I can also assign the same for this member. Again, we can use drop slab patch panel by selecting these options. Okay, as you see, you can notice these drops in 3D view. So let's continue with the steel members. Okay, in the modeling tab, we have some steel elements in here. So I'm gonna start with the columns. You can simply add these members in the 3D view. By the way, we have really extensive database that you can change all these sections from here. Also, let me show you. So I'm gonna create these columns on the axis intersections, just like this. So let's continue with the truss member. So to create a truss member, you just need to select column endpoints. Okay. Any kind of truss can be generated. You can import from DXF, or user-defined trusses can be used in the structure. For example, we can simply delete some components. For example, let me delete them. Okay, we can add, for example, some diagonals, or we can add top chord. Okay, and also we can assign bottom chord just like this. So you can just customize the truss as you wish. Okay, on the other hand, let me show you. I'm gonna use the existing truss type, which is this truss type in here. So let's say that the support placement will be top chord. You can also play with the apex height, span numbers, span length. All these parameters can be changed in here. We can also actually specify the splice position in here, or you can change the top and bottom chord sections in here. Okay. So let's continue with the steel beams. So to create a steel beam, again, I'm going to use a 3D view. You can also add some hinges for the starting and end points. So here we have different types, and I'm going to create a composite slab over here. So at this time, I will use secondary composite beam for this node. Okay, this is important for the load distribution if you want to insert composite slab. Then we may have primary composite slabs on the other side. And of course, if you want, you can use the frame group for internal secondary composite beams. Okay, just like this. And quantity can be, for example, 4. Okay. In here, we can assign composite slabs by using 2 diagonal points from here to other frame members insertion point. We can also change the mesh steel in here, or you can change the slab thickness. So any kind of adjustment can be done in here with composite slabs. So let's continue with the braces. So in here we have brace elements. You just need to select columns, and you can change the profiles, for example, in here. So I'm gonna use a bit different profile section in here. By the way, you can use built up or cold form sections as well. You can also add additional rows for braces, just like this. We are supporting X brace, K brace, V brace, or only diagonals. So you can invert them if it's needed. So we have multiple options for brace insertion. You can also use the frame members as brace elements. Okay. By the way, you can also play with the. Let me increase this section a bit. You can also change the elevation of these braces from here. For example, let's say, because there will be a connection. So what I'm going to do in here, I will just reduce this brace heights via these parameters. Now it will be more constructive in this case. Okay. So let's continue with the Purlin members. Okay, we just need to select 2 truss elements, and Purlins will be generated. You can also change the profiles from here. In our case, UPN 160 is suitable. You can also change, for example, we can also place these Purlins for bottom chord and top chord of these truss. Okay, so we have multiple options. You can remove first member because we'll have some connections, so I don't want a Purlin at this point. Okay, or you can slightly move a bit here. It's up to you. So I'm gonna add some Girt members. These Girt properties are exactly the same as Purlin ones. We can slightly move these Girts as we wish in here. Okay, I will do the same on the other side. So we have almost completed the model. What I'm gonna do, I will just talk about a bit analysis. In the analysis part, you can use different concrete classes. For example, let's say C30 for all members, or you can change your steel grade. Any kind of custom steel grade or concrete class can be added, especially if you are doing building assessment. You can add your existing concrete class from here. In the seismic parameters, you can change the behavior factor from here. In our case, it will be dual system. Importance factor can be selected. Ground type, you can, let's say that we have ground A. Also peak ground acceleration can be changed in here. We have different analysis option as you see in here. For example, you can change damping ratio, accidental eccentricity. We can increase the number of vibration modes. For instance, let's say 25 vibration modes. So ProtaStructure is performing some sophisticated, some important irregularity checks, such as soft story or mass distribution. These grayed out checks are automatically performed, but if you have, for example, non-compact plan shape, you have to set this option, and the software will automatically decrease the behavior factor. Okay, let's just click OK button, and let's talk about a bit model options. In the stiffness factors, we are automatically arranging stiffness factors for the American code, but for Eurocode, you can do by yourself as 0.5. You can also change the wall model. Generally, I'm using finite element model for slabs and actually wall models. In here, we are automatically assigning the rigid diaphragms for all stories. If you want, you can remove the diaphragm from here. So instead, you can include slabs in the building model, and you can use the semi-rigid diaphragm option if it's needed. Okay. So let's just click to Analysis tab, and in here, I always suggest this to run the building model check, because we may have some modeling issues, and before we go further, we can detect these errors from here. So let's just run the analysis. I'm going to select all design options. So during the analysis, the software will perform these design checks, such as some irregularity checks in the A2 report. Let's just click OK in this option. So what we do in here, we automatically extract the analytical model information from the physical model. So normally this kind of models may take even hours in general analysis softwares, but in just 45 minutes we have created a steel roof with 4-story buildings. So so I can say that our modeling side is really easy to use. And now it's about to run the column design. Okay. Then we will continue with the beam design. Also, it will be automatically done. Now the software is using the default settings for the design. Of course, you can customize, for example, lap positions, rebar ratios, all can be customized from settings. Okay, now it's about to finish the beam design. Then we will continue with the post-analysis part. We will just review the analytical model. I will show internal forces, some tools that helps us to review the analytical model. So we have a lot of combinations. That's why beam design is taking a bit time. By the way, I will take your questions at the end in a Q&A session. Okay. Of course, I will show the foundation part. We will have rough foundation, strip foundation, and we pet footings. So all different foundation types will be inserted in this model. Okay. So now we can pass to the post-analysis part. The software has finished the analysis. So in the post-analysis part, you can reach to the analytical model that we extracted from the physical model. Okay. Let's say that, let's check our diagrams. For example, axial loads. Okay. You can see the diagram values or bending moments in here. Okay, you can also filter any story in here and review the, for example, slab reinforcement areas. In this case, I'm going to use the first contours, okay, then envelope values. Let's say that X direction bottom rebars. So you can see the rebar areas in here, okay. Of course, with slab strips, we can collect these results, but you can also review these contour values in here. If you hover over on these nodes, you can see the rebar areas for this node. Okay, let's talk about a bit the review tab. So in here, you can quickly see the design status. As you see, some of our columns are insufficient. So what we can do, we can increase their sections, or we can increase our concrete class. So multiple solutions can be applied. You can also check, for example, additional loads or live loads. For example, we could increase our live loads for cantilevers, but we didn't. So we can quickly realize our issues via these color-coded visual interrogation feature. For example, beam sections, column sections, all columns which are used in this model will be listed in here. Okay. So let's continue with the column members. Sorry, column design. Okay. So as you see, some members are sufficient. So if you just click on interactive design, you can see that the section must be increased. Okay. So for example, you can also do some adjustments. You can add some reinforcements. But first we need to change the parameter with fixed bar. Otherwise it will not allow you to, because the default parameter is bar layout optimization method. So if you select fixed bar layout method, you can customize this reinforcement as you wish. For example, we can add some additional reinforcement just like this. You can also play with the link patterns in here. So once you click OK, this rebar pattern has been generated in this column. So we can copy this reinforcement to all similar ones, okay, with the paste bars to all, just like this. You can also take generate design report. You can have rebar table, strong column and shear checks can be performed in here, but we didn't check our beams, so I will not show them in here. Okay, let's continue with the beams. You can filter if there are some failed members. So in here we don't have any insufficient beams. So actually recently we have added a detailed report. So in this detailed reports, you can quickly follow the formulas regarding to the selected code that we used in calculations. Okay. For instance, like so left section, bending design, shear design, all formulas are placed in this detailed report. You can also check the joint shear check. Also, we can obtain this report for all members, but I will just show for this element. If it's insufficient, you can see in the notification, just like this in here. So what we need to do, we can adjust the reinforcement, or we can change the sections. Similarly, you can generate a strong column checks. Also, we have some insufficient elements. So we can simply increase the column section to satisfy this a strong column weak beam check. Or of course, you can, if you want, you can weaken the beam as well. So let's continue with the foundation part. Okay, in the foundation part, let's go to the plan view. In the foundation part, what we can do, we can add some pile caps. For example, I will just select all these columns and we can add pile caps. So you can simply right click and select the insert pile cap command. In here you can redesign all and the software will automatically design all these members properly. Okay, you can also add some pad footings. Similarly, we will redesign all these pad footings. You can see the design status in here. Okay. And lastly, we will have strip footing and a rough foundation on the center. So let's just create a beam. Let's say we have a beam 35 centimeter, which has 35 centimeter width and 90 centimeter height. Okay, just like this. You can draw this beam along the columns, and it will be automatically splitted just like this. So we can simply select these beams and insert strip footing. Let me select again, insert strip footing. In here we can use the design envelope. You can change the cantilever length as you wish. Also footing depth can be increased from here. You can simply click on the design and strip footing will be placed just like this. Also, I'm going to create a rectangle for the rough foundation, and we can simply add a slab inside of this rectangle edge. Let's say that we have 50 centimeter slab thickness. Concrete cover can be 50 millimeter for the foundation part. So what we can do, we can add some slab strips for our foundation design. So in here we can use a bend strip for this purpose, and we can press the control button to create a straight slab strip. Okay, you may have some peak points, peak contour values for the reinforcement. So if you want to smooth this reinforcement nodes and to use the average values, you can use the integral strip option. Okay, and we can specify the edges of this rough foundation. So on the Y direction, I'm going to create again another strip, but make sure that these strips are straight. Okay, otherwise your reinforcement will be drawn with the same angle of this slab strip. Okay, now what we can do, we can run the analysis of finite element foundation. You can see the analytical model, finite element model of this foundation. Let's just click OK. So once you display the analytical model, you can review the, for instance, soil pressures. So let's just click soil pressures. So in this case, it's lower than 200 kilonewton square meter. Of course, we need to check in envelope values as well. It's a bit actually more than the limit, so we can increase this slab in here. So let's check some reinforcement for the X direction bottom steel, Y direction bottom steel. So all can be reviewed in here. Okay, you can simply right click and update steel bars. So lastly, I would like to talk a bit in slab design. We have multiple options. You can use analytical method, which is refers to moment coefficient method. So you can simply draw the slab strip and instantly you will see the reinforcement in here. Okay. So let's draw all strips just like this. Okay, and lastly, if you want, you can also add on Y direction quickly. So it will not take too long. So, and make sure that you are selecting correct boundary conditions. Otherwise, you can see the error messages like section insufficient, because sometimes clients are forgetting this option, which is for cantilever. So okay, on the first story, as you remember, we have meshed the slabs, so we can use the finite element result collection method. I'm gonna use the finite element strip. The result source will be building analysis, because we will collect this result from the building analysis. And again, I need to select the correct boundary conditions. Okay. So the next one will be, there will be a cantilever. So I selected this cantilever option at the end. And you can quickly create your slab strips just like this. Okay. So if you want to take the report of these slabs, you can go to the slab analysis design and you can have the design report from here. So all members are sufficient regarding this design status values. Okay, so let me show the final part of this model. And what we can do, we can pass to the ProtaDetails side. So ProtaDetails actually is a CAD software that you can move members or you can copy elements. So most of the CAD commands are working in ProtaDetails. And the magical part of this software, you can generate all reinforcement details with a single click. So you will save really huge time once you create details from ProtaDetails. Let me show you. Normally, preparing these kind of details is really time consuming. So what we can do, we can use different options. For example, I can change hatch patterns from here, or we can select different options. For example, I want to see the links next to plans. Okay, we have multiple options. I would like to insert members to the sheet, so we have multiple sheets in here. You can also change the scales. By the way, you can adjust your own sheet and title block as in our library, so you can add your own title block to our library and use in ProtaDetails. So let's just draw all members, all member details, plan views. It will take just a couple seconds. Then we will continue with we have some macros, important macros in the design library. So I would like to talk a bit for these macros. And lastly, we will see a part of steel detailing after the ProtaDetails. Now it's creating the wall details. Okay, so in ProtaDetails, by the way, I forgot to say, we are creating reinforcement with some intelligent properties. For instance, you can quickly change the diameter or rebar length, and it will be automatically updated in the quantity table. And instantly, you don't have to do anything. By the way, I didn't mention, but we have plenty of different reports, and all these reports can be combined in our report manager. We are also automatically preparing the content table for our reports. So the software ProtaDetail has prepared our details. All these reinforcements are intelligent. For example, if you just select this reinforcement, you can reach to properties. For instance, let's change the segment C's length. For instance, let's insert 350 millimeters. Okay. So once we change this reinforcement, this rebar, it will be automatically updated in the quantity table. So let's go to the number 11 in quantity table. And as you see in here, the bob length has been changed as 350 instantly. Okay. You can see our shear wall details, which is prepared precisely. Okay. Also column details. We are also, you can see the confinement zone, because we have selected high ductile class, so structural system. So that's why you can see these confinement zones. Okay. By the way, if you want, you can also play with these column rebars as you wish. You can change the lengths. It's up to you. So you can also see our beam details, which is precisely prepared in here. Normally, preparing these details are really time consuming. Okay. Of course, if you want, you can just move, or let's move this detail a bit here, a bit above. Okay. So you can use copy, hatch, trim. All these commands are working in the ProtaDetails environment. You can see our head footing and also pile caps. By the way, we forgot to design strip footings. So if you want to have the detail of strip footings, you need to run the design of foundation beam, then you will see the detail of strip footing. Okay, so let's continue with the design libraries. In here we can add, for example, retrofit wall, just like this, or you can add, you can generate retaining wall detail. Let's say we may have shelf, shear key. We have multiple design options, for example, Eurocode, American code, or Turkish code can be selected in here. Okay, let's go to design part, and you can change the reinforcements in here. You can see the prepared, actually selected rebars. So let's prepare the drawing. And all these, by the way, all these reinforcements are intelligent reinforcements, so you can play with the properties. Also, if you just right click on the retaining wall, you can get back to the properties and revise your retaining wall as you wish. Let me show again. Just like this. Okay, so let's continue with the stairs. For example, you can select any kind of stairs in here, and you can generate details of it. Okay, by the way, if you want to export this drawing to the DWG, you need to save it first, then you can export this drawing to the DWG with this command. You just need to double click on it and click to the export button. So at the last part, we will talk about our ProtaSteel features. So I will start with the IntelliConnect feature, which is our revolutionary feature that can automatically assess the joint and select the most appropriate connection for the node. So let's start with the IntelliConnect. In here, what we can do, we can select, for instance, all steel members. Let me select like this, and then, for instance, we can run the Purlin checks. Of course, we have different types of Purlin connections, but I will just use the default one. Okay, so you can quickly review that all Purlins are automatically connected. We can also continue just like this, and can add our Girt connections. Okay. Also, in just couple seconds, we can add our Girt connections. Let me show you in here. Okay. So let's continue with the truss connection. To create a truss connection, we can use the here we have create truss connections over here. Then you can simply press the run button. Okay, now it's creating the truss connections. Only bottom of apex cannot be generated, but we have a macro for this purpose. So you can simply select the apex truss gusset, first main member, then secondary members, and the connection will be generated. The main members, secondary members. I couldn't, so again I need to create. Okay, main members, then secondary members, and that's all. Okay, so let's continue with the base plates, for instance. So we can use our base plate connections. You may have simple base plate, or let's say base plate with stiffeners. So let's select base plates just like this. You just need to pick the column, and that's all. As you see, stiffeners and our brace members are colliding. So what we can do, we can remove some of the stiffeners from the macro settings. So if you press to enter, if you select members and press to enter, all macros will be listed as a grouped members. So we can modify these grouped members via the interface of baseplate connection macro. So I just removed P2 and P4 stiffeners just like this. So now we can clearly see that there won't be any colliding with the stiffeners, just like this. Okay, let's add some connections. For example, I'm going to start with the column beam connections in here. So let's start with the hunch connection. Okay. By the way, the software couldn't extend the column height automatically, but we can do this manually. You can just double click on it and specify extra length in here. Of course, if you want, you can adjust, you can apply this adjustment to the others by match properties, match elements command. Okay, if you just select the extended column, it will be applied to the others as well. Okay, I would like to show that we can also modify macro settings. For example, what we can do, we can add extra stiffeners for the hunch connection, as you see in here, or of course we can copy this hunch connection to the other side, or we can mirror, it's up to you, or simply you can do the same connection on the other side as well. Let's do the same stiffener setting on the other side. Okay, so we can use, for example, stiffen end plate connection as a simple connection in here. First, we need to select the column, then turn off the cut objects. Okay, and that's all. You can do the same on the other side. You can also use different connection types. For example, let's say again, stiffen end plate connection in here. Okay. You may have, for instance, extended end plate or directly end plate connection over here, just like this. And of course, we have different beam-to-beam connections. Let's say again end plate connection, or you can use the thin plate. Okay, so different options can be used. Also, let's say that we have stiffen end plate connection in here. Okay, let's continue. We can also add some connections over here. For instance, you can use fin plate connections as beam column as well. Okay, in here I will do the same. Okay, so let's continue for brace connections. Okay, we can add, for example, bolted gusset plate at this point. So I'm going to use the bracing connections, bolted gusset plate, first main member, then brace, and at the end you can select the actually plate which is limiting this member. Let me revert it back. Okay, because I couldn't select the plate member, so okay, now it's good. So I will do the same on the other side. First main member, then brace and plate member which is limiting this brace. We can do the same in here. Again, of course, if you want, you can use welded connections as well. For example, welded gusset plate. Again, I'm going to use the welded gusset plate on the other side. And lastly, I will add a connection at the middle, so we can quickly use bolted gusset plate for this purpose and right click. Okay, so we almost finished the connection part. We can also add some ancillary objects. For instance, you can add some ancillary steelwork, for example, handrails. You can connect these handrails as you wish. Okay, so handrails can be added just like this. In here we don't have handrail, so but you can add as you wish. You can connect these handrails. Anchor bolts can be assigned. For example, let's just right click and select the plate. Okay, if we hide this member, you can see the anchor bolts. Of course, these members are customizable, so you can simply get into the macro properties and change the anchor types as you wish in here. Okay, let's continue with the detailing, some detailing macros. You can add, for example, stringer holes for stairs. You may have multiple web openings in here, just like this. Okay, or you can add, for example, you can automatically add fitting objects or cut objects as you wish. We don't have splice connection, but if we could have, we would use a splice connection. So let's talk about a bit detailing part. Okay, so what I'm gonna do, I will just create detailing cubes. Okay, for the perspectives. So in the via detailing item manager, let's say detail A. Okay, detail A. I'm gonna select the objects that I want to see in this drawings and right click. We can also add 3D views for this purpose and close. So we can also have the same in here. Again, detailing item manager. Of course, you can insert different names, for example, base plate or different names as you wish. So I want to see profile and this brace member in my detail. And lastly, I will create a detail for this brace connection. So again, let's just select this small part and we can create a detailing tube for as detail C. Okay, we can select the only brace elements and right click. If you want, you can add 3D view for this one as well. So what we can do in here, I will just unhide all. In here, first we need to number the elements. Okay, perform numbering. Of course, you need to pass to detailing side if you are sure that there is no any collided members or there is no issue with the model. So for this purpose, we have some tools that you can check clashes. Let me show you. For example, you can quickly run the clashes. These highlighted members are clashing. Okay, or you can use the audit model option to detect, for example, duplicated members or, for example, some weld issue we have. So you can simply select these issues, review in the model, and we can do some adjustments if it's required. So let's go to the drawing part. We can simply use the Control D and F6 button. We can generate drawings, let's say general arrangement. Okay. By the way, okay, this angle is good. By the way, I forgot to say we can quickly generate views from grids. So views are important because we are using them for the detailing purposes. So create views on grids. So all these views are generated from these grids. Okay, but if you want, you can also draw this view manually. It's up to you. You can simply select the column centers and the view will be generated just like this. Okay. So now we can pass to the detailing part. We already created a drawing, but let's create again. Okay, so what I'm gonna do first, I will draw a 3D model. Of course, we can adjust this 3D. For example, we can change the drawing mode, or we can hide the unnecessary members. I just want to see, for example, profiles, plate, bolt, and weld members. Okay, and once you click on apply button, you will have a more clear 3D view in here. We can also add, for example, section, and you can see the highlighted nodes which has detailing cubes. Okay, So in the tools part, you can quickly generate all connection detail drawings by selecting this button. Okay, all these details, for example, base plate. You can see the brace members and also stiffen end plate connection. So what we can do, we can add annotations. For example, let's say that we have annotation settings in here, so you can add any information in here. But I just added profile, name, and ProtaStructure ID. Okay, you can simply select the members and add annotations accordingly, just like this. Also, you can place these annotations as you wish, or you can enlarge this windows from the corner points. Okay. So in here, we can add some dimensions horizontally, vertically, or aligned numbers, actually aligned dimensions. So let's just pick the corners. I couldn't, yeah, no. We can quickly select corners just like this. Of course, if you want, you can delete these nodes or add new dimension points from here. So let's just save this drawing. And I would like to show part and assembly drawings. For example, to create assembly drawings, we are automatically generating part and assembly drawings. So we can quickly select the assembly drawing. But before, I suggest you to use select assembly command, because let me check. Sorry. Because if the assembly is not correct, detail will have problem. Okay, select assembly. For example, in this assembly, the software is also selecting the brace member. So what I need to do, I need to change this weld connection in here, because this is probably this weld position is probably operation location is workshop, so that's why it's also selecting for assembly drawing. So what I need to do, this weld will be done on site, so I'm going to select on site and apply. And now the assembly detail will be better, because in reality there won't be any brace connection in the assembly detail of this column. Okay, just like this. So let's prepare again assembly drawing. First, let me delete this. Okay. I'm gonna recreate this assembly detail. So once you press the F6 button, you can review the assembly drawing of this column. You can see part drawings, actually part details, all of them are dimension. Okay, weld marks in here, and also material list with bold lists. So if you want, you can only generate the part detail, part drawing of this column. Of course, there won't be any plate or bolt members in this detail. Okay, F6. Lastly, you can see the part detail of this column and material list in here. So lastly, I would like to show that we can quickly review the color-coded actually connection designs. Okay. So as you see, this the members which has red ones. Okay. These red colors represents the actually insufficiency for these connections. So as you see, these green ones are sufficient. Okay, you can also review this information in the design summary. So we are also providing all actually issues or any insufficiency in the design summary report. We can also let me show or a sample report. For example, let's generate a sample report. I know that webinar is actually a bit long, but soon I will finish. So in here you can see that we are providing also formulas regarding to Eurocode 3, and of course you can also select all connections and obtain the their actually design reports at once. So lastly, I would like to show material takeoff part, so we can quickly prepare the material lists in here. For example, you can see that plate lists, profile lists in here, again profile lists, rebar lists. We can even provide the washer numbers in here, washer list, or yeah, even bolt lists in here. So lastly, I would like to send this model to the IFC file. Okay, I'm gonna create an IFC on the desktop. You can also export properties to the IFC, like profile name, some profile details. Let me show these IFC in here. So in our IFC, we are also generating, for example, bolts, welds, all members which are generated in ProtaSteel are being sent to IFC file. You can see welds, bolts. So we have really detailed IFC file in this case. So lastly, I would like to finalize my presentation. You can reach our help center to review our articles or some videos provided in here. You can check our website for white papers, webinar recordings, tutorials, and please subscribe to our YouTube channel. You can follow our latest videos from here, and you can contact us via our LinkedIn, YouTube, Facebook, and Instagram. accounts, you can contact with us via globalsales@protasoftware.com or www.protasoftware.com.
Okay, thank you very much. And I would like now to close this session and give you some closing words. So this was an informative webinar for ProtaStructure Suite, and I want to express my sincere gratitude for all of you to have participated in this session. Today we have explored the powerful capabilities of ProtaStructure Suite and how it can revolutionize our approach in structural analysis and detailing, from its advanced BIM capabilities, automated modeling, and comprehensive analysis tools. So I think that this software is quite powerful and promises to be a game changer in our industry. I think that all of you that participated in this presentation have a more clear view and understanding of how this program can be used in your work and how it can contribute to all of your projects. In the end, I would like to extend a special thanks to Mr. Volkan Öğüt for his expert guidance in the features and applications of the software, because his experience and insights are very invaluable for understanding of the full potential of this tool. And as we move forward, I would like to encourage everyone to consider ProtaStructure Suite to be integrated in your projects and your workflows, because adopting new technologies is not just about improving our individual practices, but about pushing the boundaries we can achieve in the engineering community. So for all those interested in learning more or getting started with ProtaStructure Suite, our team is available and can provide further information, support, and guidance. And we are committed to ensure that you have all the resources needed to make the most of this powerful software. So thank you once again for your time and attention. I wish you all success in your future projects, and have a great day ahead. Thank you.
Okay, see you.